Okay, let's look at some of the solutions for the problems from 5.1 and 5.2, graphing linear inequalities. First, graph the following linear inequality. Y is greater than or equal to x plus 3. Following the steps that we outlined, graph the line as if it were an equation. You're going to use a solid line as the border region. You can graph this by using the same techniques we used to graph linear equations, finding the x and y intercepts as convenient points to form the graph. If we choose the point 0, 3 and negative 3, 0 as our intercepts and then connect them, it forms the border region. Now choose a convenient point to test. Once again, the point 0, 0 will work here. When we substitute that into the original equation, we get the statement 0 is greater than or equal to 3. That is a false statement, so the other side of the border region is shaded. See graph. Number 2. Graph the following inequality. 4x plus 2y is less than or equal to 8. Once again, we're going to graph this as if we were graphing a linear equation. The intercepts of 0, 4 and 2, 0 provide convenient points to connect. The border region is a solid line because this is less than or equal to 8. And if we choose a test point, once again 0, 0, we see that when we substitute that in, it forms a true statement, 0 less than or equal to 8. So the same side as 0, 0 is shaded. Once again, see the graph. Number 3, solving a system of linear inequalities. This one is formed of 3 inequalities. 6x minus 2y less than or equal to 12. 3x plus y is less than or equal to 9. X greater than or equal to 0 and y greater than or equal to 0. So this actually is made up of 4 inequalities. For the 2, x greater than or equal to 0 and y greater than or equal to 0, the border regions for those are the y-axis and the x-axis respectively. So keep that in mind when looking at the solution. For each one of these, especially the first 2, you should choose test points to decide which side of the solid lines are going to be shaded. To find the solution region of all 4, we want to find the region that is common to all 4. See the graph below. Notice that the region is what we refer to as a closed region. It exists between the x-axis, the y-axis, and the 2 lines. It is a 4-sided, 4-cornered solution region. Notice that in graphing the 2 inequalities, to provide a complete solution, you should also find the corners of the region. In doing the algebra here, including the origin as one of the corners, notice that we end up with the points 0, 9, 2, 0, 0, 0, and 5 halves and 3 halves.